Alright, in the second day of product and quotient rule, what we're going to do is just look at using the product rule and quotient rule again, as well as taking it just to the next step. So on this one, this happens to be a product rule, if you want to use a product rule, or we could distribute, but actually if we distributed, we'd have two things being multiplied together and we wouldn't know how to take the derivative of sine squared. So we definitely just need to take or do a product rule in this question. So we're going to do first times derivative of the second. So I'm going to say that f prime is equal to first times derivative of the second. So the derivative of sine is cosine x plus the derivative of cosine is negative sine x plus the second times the derivative of the first. The derivative of sine x is cosine of x. Now what I'll do is I'll go ahead and distribute this through because I need to compute this for pi over 4. So I'm going to have sine x cosine x minus sine squared x. This is back from, you should have learned this already, but sine x quantity squared could be written as sine x squared. Sine squared x, plus, distribute this direction, we have sine x cosine x plus cosine squared x. The only thing I can do is put those sine x cosine x's together, so I have 2 sine x cosine x minus sine squared x plus cosine squared x. We're supposed to figure this out for pi over 4. So I have 2 times sine of pi over 4 cosine pi over 4 minus sine pi over 4 quantity squared plus cosine of pi over 4 quantity squared. The sine of pi over 4 is square root of 2 over 2. The cosine of pi over 4 is square root of 2 over 2. And then I have minus, this would be the square root of 2 over 2 squared plus the square root of 2 over 2 squared. What that comes out to be then is, this would be 2 over 4. 2 times 2 would be 4 over 4, so that would be equal to 1 minus, this would be 2 over 4, which is 1/2. And then this would be plus 2 over 4, which is 1/2. So these create 0, and so my answer is just 1. The next time I have a quotient rule, if x is being multiplied or divided, so I know it's quotient rule. So I want to use quotient rule here, bottom times the derivative of the top. Well, the derivative of the top is 1, so I'm not even going to write it. Minus the top times the derivative of the bottom, which is 1, all over bottom squared. Well, I'm going to simplify this just a little bit because it actually works out to, I have x plus 1 minus x, and then this would be plus 1 over x plus 1 squared. X's cancel on top, and I'm left with 2 over x plus 1 squared. So to compute this for 2, so the derivative at 2 would be 2 over 2 plus 1 squared. So that would be 2 over 3 squared, which is 9. So 2/9 is the answer. It does ask you to find the equation of the tangent line. So we can write that using point slope form. Y minus the y coordinate equals my slope times x minus my x coordinate. This one asks me to determine the point at which the graph of the function has a horizontal tangent. Horizontal tangent lines occur, as we've talked about previously, where you have some function and you draw a tangent line to the curve and it makes a horizontal line. Well, what's that tell you? Well, it tells you that y prime is equal to 0. So I'm going to take the derivative of this and set it equal to 0 to see what we figure out. So I've got a quotient rule, bottom times derivative of the top, minus the top times derivative of the bottom, all over bottom squared. So I end up getting on the top 2x cubed plus 2x minus 2x cubed all over x squared plus 1 squared. So these have canceled, and I really just have 2x over this x squared plus 1 squared. What I want to know is, where is this equal to 0? So 2x over x squared plus 1 squared. Doesn't really matter about the bottom as long as it never equals 0, which we're not even looking for that. We're just looking for where this equals 0. So really, it seems like a really silly thing to do, but you can actually cross multiply and realize that the bottom falls out, and you're really just concerned with the top. Where is the top equal to 0? Well, when x is 0. How do you find that point? Well, you have to take this x value and plug it back into the original, because that's what y is equal to. And when you do that, you get 0 over 0 plus 1, so your y value is 0. So the answer, or where this occurs, is at 0, 0. Well, my next problem is asking me, or telling me, that the radius of a right circular cylinder is given by the square root of t plus 2. So I'm saying that my radius is square root of t plus 2. It then gives me the height in terms of t, 1/2 square root of t. So height is 1/2 square root of t. Where t is time in seconds and the dimensions are in inches, find the rate of change of the volume with respect to time. So volume of a right circular cylinder is volume equals pi r squared h. Now it's asking me to take the derivative of the volume with respect to time. Well, I can't do that until these are in t's. So we can't just jump to this step. What we need to do is we need to replace our r with what it is in terms of t, which is t square root of t plus 2, and I'll put squared there, times the height, which is 1/2 square root of t. So what that gives me is pi times, this would be just t plus 2, times 1/2 t to the 1/2 power. Well, I'm not going to take the derivative like this. I think it's silly. I'm going to multiply this stuff together. I get pi over 2, and then I have t to the 1/2, t plus 2. I'm going to just distribute this stuff through and make it a little easier. I'm actually going to leave the pi over 2 alone. So I'm going to leave the pi over 2 out front, because I know when I take the derivative, I can just carry the pi over 2 with me. So I've got t to the 3/2 plus, this would be 2t to the 1/2. So now I'm going to take the derivative with respect to t. So dv over dt is equal to pi over 2. Carry that along, that's the constant. We'd have 3/2 t to the 1/2 plus, bring that up front, you get 1 t to the negative 1/2. And that's as far as I'm going to take it, because like I said, normally they will give you a particular time they want you to figure that out for. This problem says a population of 500 bacteria is introduced into a culture and grows in a number according to this equation. So they give me the equation where t is measured in hours. Find the rate at which the population is growing when t equals 2. So they're just basically asking me to find the derivative. Find the rate. Find the derivative. So p prime of t. What I'm going to say to do on this one is to leave this 500 alone and take the derivative of what's on the inside. Well, the derivative of 1 is just 0, and then here you have a quotient rule. So we've got bottom times the derivative of the top, which would be 4, minus top times derivative of the bottom, all over bottom squared. Now it looks like a mess, and if you want to clean it up a little bit, we can. We can say that we really have 200 plus 4t squared minus 8t squared all over 50 plus t squared squared. And if you want to take it one step further, we can. And we can say that we have 500 times be 200 minus 4t squared over 50 plus t squared squared. I wouldn't take it any further than that. I would just leave it alone. And then I would say, well, what I'm really concerned with is when t is 2. So I'm going to plug in 2. And I'm just going to tell you, when you plug that into your calculator, please make sure that you get this, but you should get around 31.55, and that would stand for bacteria per hour. The last part of this section is something that I must do with you in class, is using your graphing calculator and showing you how to make cubic models or quartic models with data. And so we'll be entering this data into our graphing calculator and creating a cubic model to represent this data. Remind me, tell me to do this during class, because this is part of your assignment.